Yes, students. So waves. What is waves? You all have studied, right? We have studied electromagnetic waves. We have studied wave optics. So we know what wave is. Is wave energy? It's not energy. It carries energy. Then what it is? Like a carrier. Yeah, it's a carrier. Okay. Wave basically is a disturbance. You create a disturbance. But what that disturbance is doing? Carries energy and momentum from one place, like you are giving energy to this one, it's carrying, goes to other place, it is delivering. Okay, so waves is a disturbance that carry energy and momentum. Okay, fine. Does it carry mass also? No. There is no mass motion happening along the motion of energy. Okay, mass is not moving along the wave. Okay, there is no mass transfer. There is no mass transfer happening along with energy transfer. Along with energy transfer. Say how? Reason is simple. We have to go to examples. What examples we have for waves? You can say light. Light we cannot understand in terms of mass. For example, best example actually, if you want to understand waves, the best example is string. Okay, waves in string. What is the example? If we say there is a string like this. Okay, now a person is here. Okay, this person is actually holding. Okay, he is holding. Now this, what he is going to do? He is going to make it oscillate like this. One end he will be holding, he will be oscillating. So what will happen? This one, this hand, this part, which is in his hand, this he is going to oscillate, and because of this, waves will generate like this. So this here will remain in his hand, or that is also going to remain in his hand. So that means mass is not moving. This part of string, this part of string is in hand of boy. That is not moving. Where? Along with the energy. Energy is moving like this forward. That's energy. Mass is here only. That boy is only moving it up and down. So mass is not moving along with the energy. So mass transfer is not happening. Only energy transfer takes place. That's wave. Okay. So disturbance that carry energy, yes. That carry momentum, yes. Carry mass, no. There is no mass transfer which is happening along with the energy transfer in wave. Okay. Is this clear? Is it clear, students? Okay, note fast. Completed, students? Okay. Then, now question arises, all the particles which are there, which are involved in energy transfer, are they in motion? I said yes, because we talked about momentum, and momentum is mass into velocity, right? So definitely, whose momentum? Particles momentum. Some mass has to be there, right? So all the particles which are involved in energy transfer, they are not moving along with the energy, no doubt about that. Okay, but they are having motion. Which motion? Oscillation. Simple harmonic motion. Okay, so all the particles that are involved in energy transfer through wave, are doing oscillation, are all doing simple harmonic motion, including the source. Okay, including the source which is producing the wave. Okay, all the particles that are involved in energy transfer through waves are doing SHM. Remember that. Okay. Okay, fine. How many types of waves we have? Two types of waves. There are two types of waves. What? Mechanical and non-mechanical. Mechanical and non-mechanical. Mechanical one, mechanical is where you don't require medium for propagation. Where you require medium for propagation. Waves that require medium for propagation. Medium for propagation. Okay. So non-mechanical will be what? Which does not require medium for propagation. Examples? Mechanical's example is what? Sound. Okay. We require medium for sound. Example, sound. Okay. This one we will take slightly below. Okay. Here example is sound. And what else? Water waves. Then waves in string. Waves in spring. Okay. These all are forms of wave and we call them as mechanical wave. Non-mechanical. Non-mechanical means is those waves which do not require medium for propagation. Okay. Waves that do not require medium for propagation. What are these? Only one we know at the moment. Which one? Electromagnetic wave. Okay. Electromagnetic wave. EMW. Light. EMW means light. Okay. So this is the basic classification of waves. Okay. Note fast. Done? Completed, students? Okay. So mechanical, non-mechanical, one classification. But other than that, one more classification is there. What is that? One is transverse wave. Okay, transverse wave and longitudinal wave. What is transverse? Transverse means is in which we can say the medium particles. Okay, medium particles. If you talk about mechanical wave, if I am taking example of mechanical wave, this example is of mechanical wave, because medium will be required in mechanical wave. So, if medium particles are oscillating perpendicular to the direction of propagation of energy, okay, then we will say it's a transverse wave. Okay, how? As I told you, one boy is here, okay, and there is a string. Okay, so this boy is holding the string, and what is he going to do? He's going to make it oscillate. Okay, so how is the source oscillating? Source is oscillating like this, hand is oscillating like this. Okay, and how's energy going? Energy is going like this. So oscillation of hand is like this. Okay, up, down, and energy like this. So is it perpendicular? Yes. So this is transverse. Okay, medium particles are oscillating perpendicular to direction of propagation of energy. Direction of propagation of energy, then it's transverse wave. Okay, it's transverse wave. Right? So waves in string is first example. Second example. Second example is light. But that's not mechanical. Okay. In mechanical wave, I took example as waves in string. Because I cannot say all mechanical waves are transverse, remember. Okay. All mechanical waves are not transverse wave. Only wave in string I have taken example. Right. Other example of this is what? Electromagnetic wave. So waves in string and electromagnetic wave. One is mechanical, one is non-mechanical. Are examples of transverse wave. Is it clear? In electromagnetic wave, who's oscillating? You all know that, electric field. Okay, so electric field oscillates perpendicular to the propagation of energy in electromagnetic wave, in light. Clear? Students, is it clear, transverse waves? Okay, then note first, then we'll go to longitudinal wave. There also we'll discuss. Then Shall we go for next longitudinal wave?
Yes, sir.
Right. So longitudinal wave now. Right. So in longitudinal wave, what happens? Longitudinal wave, medium particles oscillate in the same direction as that of energy propagation. Okay. Examples are there? Yeah, spring, waves in spring. How to generate waves in spring? Okay, take spring, okay, maybe of this length, and take this end. This end, you oscillate like this, okay, like this way. So what will happen? Every particle in this one will oscillate in this way. So finally, this hand here, this end will also get this energy because of the vibration of all the particles in this. So this also will start vibrating. Okay, this way energy will propagate. But how are the particles vibrating? In the same direction. This is x-axis. Energy is also propagating along x, and particles are also vibrating along x-axis. Best example is waves in spring. We can understand longitudinal wave with waves created in spring. Okay. So it's example to understand is which one? Waves in spring. Okay, and what it is? It is basically when medium particles oscillate in same direction as the propagation of energy, then it is longitudinal wave. Okay, its example is what? Sound. Waves in spring I have already written. Okay, so its examples are sound, waves in spring. Okay, note that. Then okay, so that's longitudinal wave. Fine. Now one thing is clear to us that waves are mechanical. We can classify them as mechanical, non-mechanical, transverse and longitudinal. Right. So question is asked from you that can we say all longitudinal waves are mechanical? That's a question from you. You have to give me the answer. All longitudinal waves are mechanical? Yes or no? Say yes or no. Huh? What do you think? What it is? All longitudinal waves are mechanical or not? Answer is yes. All longitudinal waves are mechanical. Okay, sound is mechanical. Sound requires medium. Yes. Waves in spring requires medium. Yes. Right. Now the other question. What is other question then? Other question is, can we say all transverse waves are non-mechanical? Now it's answer, at least you tell me. Tell me fast.
No.
How? How can you say that? How can we say, Baba? No is correct answer.
Wave and strings are answers.
Yes. Yes, yes, yes. Waves in string and waves in water, both. Waves in string and waves in water, both are transverse, but both require medium, right? Both are transverse. Okay, fine. So this is yes, but this is no. Okay. Now I have written waves in water. So waves in water are what type of waves? Transverse or longitudinal? Answer is both. Both are there. Okay. This is called special type of waves. These are known as ripples. Okay. First you note this one fast. Then we'll discuss about ripples a little bit. I think our time is up. Okay. So we'll just discuss about ripples and close the class today. Okay. Note fast. Completed? Okay. Just few seconds only, nothing else. Okay. Ripples. These are basically waves in water. What are these? These are transverse as well as longitudinal. Both forms are there. Just note this one, okay? We'll discuss it in the next class. Okay? Transverse as well as longitudinal. Done? Okay, so that's it for today in waves. Okay, so we'll continue with waves in the next class. Right? See you then. Bye bye.